Okay, I'm now recording the session. And what I wanted to do today, like when I thought about face-to-face in-person tutorial, I wanted to go through a few things related to site investigation. So that will be borehole logs, how to draw cross-section. And also I want you to talk about SPT data and how to correct the data. We didn't do it in previous year, so that's for the first time we're doing this course. And I wanted to do it because in week 5, we're going to have another, well, hopefully face-to-face tutorial then. And then I will show you how we can use SPT data to estimate the liquefaction potential of soil, something that will be in one of your projects. And also SPT data, it's very important. You will see how we can use it next year when we do geotechnical engineering course. Lots of design things are based on SPT data. So SPT test, it's something similar to a TCP test. Some of you, the lucky ones, did it last week. Others will just have to watch a video. Okay, so also the way it's going to work is the whole week, everything is going to be online. So today we have this tutorial, and then we're going to have a lecture from 4 to 6 p.m. And tomorrow we're supposed to have face-to-face lab, so it will be online. So it will be the same time when it's supposed to be, according to the schedule, from 12 to 2. And then on Thursday, there was another laboratory schedule, so it will be from 9 to 11, also online. So it's same, it's going to be like same laboratory. I will still run it, even though it's the same, so that you can attend, like those who didn't attend a laboratory last week. On Friday, I wanted to go to Nathan and spend the whole day there, but well, I can't really do that because of the lockdown. So on Friday, we still have a laboratory, which is from 9 to 11, is going to be online. And then we have also a tutorial, like something similar to what I'm going to do right now, from 1 to 2. So if you you can attend one of those laboratories, you can attend laboratory tomorrow online, Thursday or Friday. It's up to you. Okay. Another thing for those, probably I'll talk about it more during lecture. So if you didn't do the laboratory last week, so you have to do a quiz, and the quiz is going to be on Friday. So I'm going to open it for the whole day from 6 in the morning until the end of Friday. And there will be, I think, about 10 questions. It's multiple choice questions and some of them analysis. Yeah, so all the labs are on, so but it's not going to be face-to-face, it's going to be online. So I'm just still do this laboratory because some of you scheduled for this laboratory and probably cannot attend on Wednesday or on Friday. So I will still do this laboratory. I will talk about the experiments that you were supposed to do face-to-face and talk a little bit of how to analyze data. And if you have any questions, I'll be happy to answer. Sorry about this one, but we have to change it to online. Well, it's out of my control, unfortunately. So we still have all the activities, but they're going to be online. So if you have a lab schedule on Thursday, please attend it from 9 till 11. If for some reason you want to attend it earlier, there is another one from on Wednesday tomorrow from 12 to 2. You can attend that one. If you want to attend on Friday, the Friday laboratory is supposed to be for Nathan students, but if you want, you can also attend it from 9 to 11, just like one of these laboratory sessions is going to be the same. Okay. So what I'm going to do first, I will go through a few slides related to SPT data and how to correct it, and then I have another set of slides about how to draw cross section. So in your first project, you'll be given borehole data, and you'll be given a map, and you'll be asked to draw cross section. So cross section is probably like, as I like to say, bread and butter of geotechnical engineering. So you need to know how to draw it. And if like after a few years, if you don't remember how to do it, at least you should know how to read it. So this is something that I will teach you, and then you practice. Okay, I'm going to start with the borehole log. So this is a very common log that you can see in the industry. I think I took it from one of the projects that was done on Gold Coast. And if you didn't read my, if you didn't watch my video, I'll just briefly explain how to read this borehole. I just want to make sure that it's so. This is the borehole log. And there are a few things that it's very important to you, something that you need to know before you draw a cross section. So you know how borehole, what we do, we drill a hole in the ground. So if this is ground, so we drill a hole, and then we take soil from different depths, and then we just record it in this borehole log. So this one, it says the ground, so this is from the ground. Then another thing, I just want to make it a little bit thinner, because last time you told me that it was too thick. Okay, so this goes down from the ground, goes all the way down. So we drill a hole. As we drill a hole, we collect samples, and what we do, we also describe the samples. So here you will see a sort of material description. So what you see, you describe it. So you write fill. So and this is depth. So you see, this is the scale. This is 1 meter down, 2 meters down, 3 meters down, 4, 5. So some boreholes can go like up to 10, 15 meters, 20 meters. Depends on the type of investigation and what they really want to find. So here you will see a description. So you will see it's a different geological strata. We have clay, then we have some sand, then we have layer of clay, some sand, silty, then we have clay. Well, we have lots of clay, but you see it's kind of a little bit different. There is symbols, how to classify. So you see MH, CH. This is something that we'll talk about today during the lecture, how to get the symbols. I will teach you how you can guys get the symbols, and then we'll practice in the tutorial. Another good thing about this data, this borehole, you can look at the moisture. So moisture will give you some idea if the soil is moist. You see the symbols M. Sometimes you see W, which means wet. So if you don't know all the symbols, don't worry, because each borehole log comes with a legend. So this is just example. This is first half of the legend. There's a second half of the legend with all the symbols. And if you don't understand something or you don't remember the symbols, so you can always find them here. Like for example, low resistance, SPT, it says standard penetration test data, and then like lots of information here. So in your project, you'll be also given borehole log, and you'll be also given the legend so that you can read all the symbols. Consistency also very important, because it will give you some idea about the strength. You will see that some material F, which is firm, L means loose, and typically goes with sand, like very loose, stiff as. So it gives you some idea about the consistency and a little bit about the strength of material in the field in its natural state. Okay, so what we're gonna talk about today, it's these numbers, it's SPT. You will see SPT, which stands for standard penetration test. So it was done from 1 to 1.5 meters. And you see these numbers 1, 1, 1, 3 ones, and then n equal to 2. So I will teach you what it means. And then you will see as we go down, we have like another test here at a different depth, at depth of 3 meters, then depth 4 meters and 5 meters. So every meter, usually they conduct this SPT test. So SPT test will give you some idea about the strength of material, which is, as I mentioned before, very similar to DCP test, but it's like on a larger scale. Another thing you will see that here recovered, which is sampled. sample recovered. So they take samples at this depth, and this depth typically correlates to the depth where the SPT test was performed, because when you do SPT test, you can also collect a sample, but the sample is disturbed. So n means number. So SPT n, or SPT numbers. So in this case, n will be number of this SPT tests. And I will show you how we correct this number. So this is raw data that we get from SPT test. But there are a few things that you need to know. So, and then I'll describe it right now. Okay, so that's the original idea of this SPT test. Pretty similar to DCP, but DCP is like very portable, something that you can do by yourself. For this SPT test, you just use like a machine. Now that's what we do, using a machine. So this is just the idea of the test. So we have road goes inside in the ground, and then we have this hammer. So hammer typically has this weight, 63.5 kilos. So you lift the hammer, and then you just let it fall down. So hammer will hit this part of the machine, and then it will drive the road in the ground. So it will penetrate in the ground. And what we need to know, how many numbers, how many of these blows we need. So when we drop hammer once, it's one blow, then 2, 3. So how many blows, how many numbers we need to penetrate 15 centimeters. So if we talk about DCP tests, for DCP tests, we count the number that is necessary to penetrate this road in the ground by 10 centimeters. So in this case, it's 15 centimeters. And what happens here with the test, when they drill a borehole, they first need to drill borehole, right? And then they put this machine, CPT test, which is a sampler. So it's empty inside, it's a porous, and then they do first test, which goes for 15 centimeters, and then the count number, then they go another 15 centimeters, and out of space, another 15 centimeters. So you just go 3 times by 15 centimeters. And then for each 15 centimeters, there is a number of blows. Remember when we look at the borehole log, there was 1, 1, and 1. So this means that to penetrate at that depth, to penetrate first 15 centimeters, just only one blow. Probably soil is very soft. Then to penetrate another 15 centimeters, another one blow, and then for the third one blow. So what they do next is you will see that it says n after that equal 2. So this is what we need, number 2. So what we do is we disregard the first 15 centimeters, because we assume that when we do this test, because we first drill and then we disturb the sample. So first 15 centimeters, we assume that sample is disturbed. I mean, this ground, it's disturbed. So we it's not going to give good indication of the strength of natural undisturbed material. So we just disregard it. So what we do, we just count these two. We just put them together. 1 plus 1 is going to give you 2 blows. So that's what we need. So, and this is what we called SPT, and then n number equal to 2. So if we go back, I'll just go back. You will see that here, sorry, we have 1, 1 equal 2. Then this test, you see we have 4, 9, 10. So 4, it's a number of blows for first 15 centimeters, 9 for second 15 centimeters, and 10 for third 15 centimeters. Altogether, it gives you 19. So, okay, I'm looking at what happens if one blow goes past the initial 15 centimeters. Well, that happens very often if the soil is very soft. and then it just counts as one. So you just have to adjust it a little bit. This kind of happens very often, like next to the surface when the material is very soft. You just really either adjust it a little bit or take a note that the materials are soft. Sometimes you just make like, if it's like very soft material, you do just one below, and it can go even through like 15 centimeters. It's not very common, but it can happen. But typically, well, you will see that here in this Borehole log, um, there's 111, which is pretty very soft material that will give you like at the depth of 1 meter. And if you look at the material description, it's all feel. So it's like kind of sandy material, which is feel, probably not very well compacted. So this is common again for like ground surface material feel, which is not naturally compacted. So each number for 45. Okay, so yeah, so in this case, that number which says n equal to, for example, 19 or n equal to 7, that's that's for 30 centimeters because you have two numbers, you put them together, the last two numbers, so that's for 15 centimeters and 15 centimeters. So it will be for 30 centimeters, not for 45, because we don't count the first 15 centimeters. That soil is disturbed due to the drilling process. So what I would like you to do is I would like you to be able to understand these numbers. And another thing is that this test is very popular, probably like the most popular test to do during site investigation. And it's been done for many years, and it's been done in different countries, and it has slightly different setups for different countries. And that's why we need to correlate the data. And because all these procedures typically designed for SPT numbers, which are correlated. And I will show you how to correlate it. It's a simple procedure, then we'll do just exercise together. So what we need to do is when we go, and I go back to the slides, so you will see that we leave the hammer and we drop it. Unfortunately, not 100% of energy will be transformed to the road. And from the past experience of many engineers, so they will say that it's going to be about 60% of the whole energy that actually will be transferred to the road that will drive it on the ground. So that's why most of the time we would normalize this test, this SPT numbers, to 60% of total energy. It's the average number 16. Maybe for some machines, maybe it's a little bit less, but some a little bit high. But this is just an empirical number that we just accept. So we will correlate to 60% of energy. And this is what we call N60. So it's not N anymore. It's going to be N with small case 60, which means it normalized to 60% total energy. And to do that, we just need to get these coefficients. And these coefficients typically comes from, well, it depends on the type of hammer, depends on the rod length, sampler, and borehole diameter. So 60 means that this SPTN number, this number was normalized to 60% total energy, because from our experience, from engineering experience, not like the whole 100% of the energy from a falling hammer will be transferred to the road to drive it on the ground. So there have been lots of studies, and they said it's only about 60% of the total energy from this test from the falling hammer will go. So that's why it's 60. So you'll see in the literature or in design, you will see that and 60%. So this number just comes from Borehole log. So this is the number here. And then we need to find this coefficient. This coefficient is the combination of a few different coefficients. So it depends on the type of hammer, rod length, sample, and borehole diameter. We're going to get this correction factor. So what you just do, you have this table in front of you. You read the description of the test, see what was used, what equipment was used, and then according to the description, you just find the correction factor. And another thing that was highlighted during engineering experience that this test also depends on at what depth it was conducted. So when you conduct it right on the surface, these numbers will be slightly different compared to, let's say, you conducted maybe 10 meters down, right? So in this case, they also came up with this another normal, normalized factor, I will say, so which is called overburden pressure. So this is the pressure that you still don't know how to calculate it, and I think I will teach it to you in week 4. So not next week, because I think next week is trimester break. So the week after, in week 4, I will talk about stresses and how to calculate this effective stress, overburden pressure. It's pretty simple. I'm not going to talk about it today, but for the example that we're going to do, we'll just assume some number. So in this case, as we go down, this overburden pressure will increase, and it will have some effect on these SPTN values. So, and this effect comes from, well, we can reflect it in this coefficient, which is called Cn, and this coefficient is to normalize this SPT and numbers to overburden pressure. So what I would like to do now, we'll just look at some examples. I'm going to go to next slide, and we'll just do it together. So let's assume that there was a test, SPT test data, conducted at 3 meters. And when we conducted this test, the following data was obtained. So this is something that you will get from Borehole log for 910 and equal 19. So for this particular test, let's say it was done in New South Wales, they use hammer, which is donut type, and use free fall. That is commonly used in Australia. Rod length was 5 meters. We use a standard sampler to perform this test, and borehole diameter was 115 millimeters. So this is something that you just get from the field when you perform this test. So that's technical data from the machine, from the equipment. And this one, we just assume the effective stress of 60 kilonewton per square meters. When you work on a similar problem by yourself, you're not going to assume, you're going to calculate it by yourself, but as already mentioned, I will teach you how to do it in week 4. So what we're going to do next, we are going to normalize this SPTN data, this N number to N160. So we will normalize it to the energy of 60%, and we also normalize it to the overburden pressure. So the way, well, the first step, we'll just need to get all these coefficients. So we'll see what we have. So first of all, what is going to be the N number, raw SPTN number? It's going to be 19, yeah? So you see, again, we disregard the first 4 blows, and then we just count 9 and 10. So 9 plus 10 is going to give you 19. So 19 for 30 centimeters, right? Okay, 19, and then we're just going to look what we have. So we have donut free fall. Where is it? Australia here, donut free fall. So in this case, CH is equal to 1. So actually, it's don't need to change the number because it's 1. Then rod length, it's given 5. Okay, so it's from 6 to 4. So in this case, the coefficient CR will be 0.85. Next one, sampler. Well, we use a standard sampler to perform this test. So in this case, CS, it's 1. And the borehole diameter was 115. Okay. So the coefficient doesn't have to change anything. Coefficient for borehole, it's 1. So these are all these values to get CER for the energy. Now we need to get this coefficient and normalize to the overburden pressure. So we just use this formula. I'm going right here. And it's equal to 9.78 square root of 1 divided by, so it's given to us 60. So kilonewton per square meters is the same in kPa, same thing. When I did calculation, it gave me the factor of 1.263. 1.263. So now we are going to find this N160. So we have a number of we have 19, which is the number SPT number, times CH is 1, times here it's going to be 0.85. Then we have again times 1, then another 1. And finally, we'll normalize to the overburden pressure. We multiply by 1.263. And according to my notes, it's going to be 20.4. So this is the value that we are going to use to estimate in week 5. We're going to use this value to estimate the cyclic stress ratio of soil, and that will give us good indication about if the soil is susceptible to liquefaction or not. So I'm going to teach you procedure in week 5 how to do that. So, but before we use that procedure, you need to know how we correlate this SPT data, 20.4. So later on next year, when you do geotechnical engineering course, they will also teach you how to use SPT and data for a design of earth structures. But this is the fundamentals, so and numbers and how to correct them. So it's good if you know it right now. You have any questions? Unit list, yeah. So it has no units. It's just a number, so it has no units. 20.4. Well, videos to watch. I'm not sure if you've done this or not, so you can find it on YouTube channel. So this is another example. I actually explain how we use data from that borehole. I think I use like that number 19 here. And actually, I also showed how to calculate overburden pressure in this video. So you can probably watch it when you work on your project. So there will be something similar. You'll be given the borehole with SPT data. So you'll be asked to correlate, to correct SPT data. And then I use that SPT number to estimate the cyclic stress ratio. So this is something that we'll talk about also in week 5. Yeah, please be sure to like my videos. And okay, this is something that, oh, I think somebody turned on the mic. This is something that I plan to do it in week 5 when hopefully we have face-to-face tutorial. So I'm going to teach you this procedure. I never did it before in this course, so this is the first time this year. So this SPT numbers and this procedure, because I thought I would like to teach you a little bit more, and this is also helpful for the future as well. So this is not something difficult. I will teach you, but if you want to have a little bit of knowledge before that tutorial or this video, this one it's about how to read borehole logs, and well, I talked about it today. That's up to you. If you want to review that material, will be good. So this is just extra things for you to do. You have any questions about SPT test and how we correct the data from SPT test? If not, I will go to borehole logs and how to draw cross section. Okay. So what I would like to do is, by the way, guys, did you download my book? It will be helpful if you can do that, and it's free. You don't really need to buy it. So I just want to show you something. Um, this is my file. So you will see, well, your first project will be, I wouldn't say like very similar, but like quite similar to what is written in the book. So you'll be given the map, and you'll be also given this borehole logs. So something that I talked about this morning. And then you see it has all this information. The borehole logs will be different. So every year I change the borehole logs data. And then you also be given a set of this one SPT set of data on plasticity, grain size distribution, something that you will learn late in this course. And then you'll be asked to analyze the data, and you'll be also asked to draw a cross section. So to me, cross section is very important, because when geotechnical engineers, they deal with soil and what is underground. So we need to have a good understanding of what is underground. So this is the kind of cross section. This is like kind of like a simple one. This is something that I would like you to draw as part of your project. And also I would like you to learn today how to draw this cross section. And I will also, if we have time, I will talk about common mistakes that students make. If there is no time, you can look at the slides which I shared already with you. They're available on course content. So this is the cross section of that map. And I will now show you how we do that. Do you know how to draw a cross section? Anybody has done this before or something similar? Maybe you already know what it is. Anybody has done cross section before? Never seen this before. Okay. Something seen very long ago. Okay. That's cool. Did you draw cross section at school? What kind of school did you go to? Is this like some kind of a geological school or something? But this is very good if you know how to draw cross section. It's not really that difficult. There is just few things that I'm going to explain to you. And again, it's all about some project in biology. Okay, maybe there was cross section of something like animal, or I don't know. Some
Look, it was probably a cross section of something else, but it was a cross section.
okay. Okay, so well, there are always like different cross sections. What you do, like you just cut through and then see from the like side view, like see what's all about, right? So what I'm gonna teach you right now how to just the basics, how to draw a cross section. and then you just probably practice as part of your project. Yeah, the slides are available in the content. So if you go to the that big table, all the slides that I showed you today, and like usually I upload them beforehand. So that should be available. Go to the course content week 3 in-person tutorials. So there will be like few videos and recommended. Also the slides should be there. Okay, so this is slides that I prepared some time ago, but I still use them to explain how we draw cross section. So with the cross section, when do we start our projects? Yeah, that's a good question. You start your project, it should be 10 days before the deadline. So the deadline is on week 8, so I'm gonna upload it, I think, end of week 6. So you'll start working on it on the first one. Okay, cool. Great. Okay, so I'm gonna show you a map. So this is just like part of the map. You probably have seen maps before. So this map shows elevation contours. So 10 means 10 meters. So that shows you the elevation. And also what you can see, it's scale. I'm not sure if you watch my video how to read some maps, but if you did, so that's good. So you know how to read the scale. Anybody can tell me how we read the scale if we change it to 1 centimeter? How many meters it's gonna be if you use the scale? And that will be 15 meters here. Very good. I see Jacob actually watch my video, or maybe just know this. So what we do is we just remove 2 zeros from the right, and that will give you meters, the easiest way. So if, for example, if you have 1 over 25,000, this scale, so when you draw cross section, what you need to know how many meters in 1 centimeter. So in this case, we just remove these two. It's going to be 250 meters. Okay. So also for each map, you'll be given a line. So this one, line A dash, so this one. And you'll be asked to draw a cross section along this line. So I show only half. Usually it's go like this, like kind of. And the line will go all the way here. So what is going on? Doesn't let me draw. Okay, so first I think what I would like to, what is important is the best way to do it, you print out that page with the map. If you have print, I think that would be the best, and then you just use that paper to get all the values that you need to get from this map. So some people, what they do, they try to draw it like right on the screen of the computer, which is probably maybe okay, but it's not recommended because then you can mess up with the scale. So the easiest and probably like the simple way, and so that you don't make mistakes, just print out the map and do it on a paper. Also, don't change the size of the map. Don't make it like small or bigger. Like sometimes, like students like to adjust it, like maybe to fit in a page, A4 page. Don't do that because once you change the size of the map, you will change everything. Also, the scale. It's not going to be exactly the same as it is like given to you in the map. Okay, so what you need to do next is you're going to get the this scale. And then you will see where this red line that you use to draw a cross section along, so where it crosses elevation contours, so these points. So you just mark them. Here, so all the points. Please don't skip, don't miss any of those control lines. Sometimes also here we have BH1. So this is borehole data. You also need to know this one. Each borehole data comes with the elevation, so it also has elevation. It's probably written in the borehole log. So And we have another borehole here. So what sometimes the students do, they skip a few of those elevation lines and they only get borehole 1 and borehole 2 data, and then they draw cross-section only using only 2 points. No, that's incorrect. You need to get all this cross, like where this line crosses all the points. So what I'm gonna do, I'm gonna just number them 2, 3, 4, 5. Well, we're not going to do this right-hand side, but if we do, it's going to be 6, 7, 8, 9. And then the easiest way that I do, I just use a ruler. I attach a ruler to the paper. I'm going to draw a ruler. Doesn't let me draw a good ruler. Okay. And then this one is going to be 0. This is going to be, let's say, like this is rule 1 centimeter, 2, right? 3, 4. I'm just schematically. And then what you do next is you start from the first point and you measure the distance between this first point to all next points. So for example, from point 1 to point 2, in just example, 1 centimeter. Maybe when you draw, it's going to be 1.5 or maybe 2 centimeters, but you just get it from this map. Then from point 1 to point 3 will be, for example, 2.5 centimeters, right? From point 1 to point 4, 5 centimeters. And then you just continue until your last point, which is going to be like probably like 0.9 if we draw the hole, right? Maybe it's going to be 10 centimeters. So you can do that, right? And then next is you just need to get these numbers in centimeters. And then each number you're going to multiply by the scale. So if the scale is 1 centimeter is equal to 15 meters, so each of them you will multiply by 15 because you're just going to change it to meters. So in this case, it's going to be 15 meters. This one is going to be what, 75, like 75 meters. This one I don't know, just not very good at math. Let's say 50 meters, right? Just example. And this is going to be 150 meters. So all these meters you will need to know to draw a cross section. And you see that this will be the distance will give you distance, but you also need to know the elevation, and elevation comes from these numbers. You have 10 meters, 20 meters, 30 meters, 40 meters. Okay, and this is some explanation of how to do that, what I just explained. This is again what we do here. So this is when we use a ruler to measure the distance. What I recommend is that you just start with the first point and then measure the distance from the first point to all other points. Sometimes what students do, they measure distance from point 1 to point 2, and then they measure from point 2 to point 3. You can still do that, but then you might make some mistake when you change it to meters. You just probably it's okay to do that. Just like be careful with these numbers because you will need to add them when you put it as a distance here. So this is what you need to do. You just need to have these numbers along this line that will give you distance in meters, and elevation will be on the vertical axis. So this comes with here. So then for each number along this a dash line, you're going to have a point that will give you distance and that will give you elevation. And what you will do next, that is meters above sea level. Yes, that's typically meters above sea level. that's correct. Then you just start plotting those lines, those points. So that will be first point. Um, First point will be here because you see it's 10 meters elevation, uh, 10 meters elevation. Um, so second point will be 15 meters, this one. It's 20 meters elevation here. Third point will be 30 meters. 30 meters. So the best way to do it, if you can have one-to-one scale, so distance to elevation, but sometimes it's not possible because sometimes you have a distance, you have, for example, goes to 200 meters, and elevation only goes maybe to 40 meters, or sometimes only like maybe 10 meters if it's very plain surface. So in this case, you cannot really make it one-to-one scale. So in this case, this scale, the distance will be much larger scale. So you can change it. So it doesn't have to be one-to-one, but ideally one-to-one would be really good. So this is what you do. And next, you just connect the dots, and these dots will give you ground surface. So this is a ground surface that we get. And now what we need to do is we need to tell the reader or engineers who are going to look at the cross section what is underground, because this is just the surface. And to do that, we just need to get data from borehole logs. And when I talked in the first half of this tutorial, I already showed you each borehole log will come with a description. So this is just kind of a schematic illustration, very simplified. So that will first layer of, I don't know, maybe some clay. This is second layer of maybe sand. So everything is given in the borehole log. And this third layer of, I don't know, maybe rock. Another thing I didn't show you in the borehole log because it wasn't there. It's groundwater level. So there is typically groundwater level that measured in the borehole log, in the borehole, and it's recorded in the borehole log, unless there is just no water there. So in your project there will be water, so you also need to put water. So what you do is for BH1, you're going to find the location of BH1 on this cross section. So, and then you also need to, this one, you just need to label it so everybody knows it's BH1. And then you either draw as here when you use kind of, you use color to show the material, or what you can do is, if this is your surface, and this is your BH1, you can write BH1, and then you can just draw a straight line, and then you don't really need to draw those squares with different color. What you can just do, show the boundary of each layer, and write here, for example, sand, clay, and whatever you have here, maybe rock. Okay, that means it's halfway between contour 10 and we just assume it's 15. No, so we don't assume it's 15. So you just need to read the borehole log, and borehole log will tell you the exact elevation. And that's the exact elevation that you're going to put there. We just all borehole logs come with the elevation. This is what you're going to get. Sometimes it's not written here on the map, but it's written in the borehole log, and that's how you just know the exact. What did you do? 0.5 and 15. It's 0.5 the distance. I'm not sure about why did you do 0.5, 15. So this is just 0.515. It comes from this example, the example that was in the slides. It's not example that I drew on the that I drew here. So why they do 0.5? So I measured it was 1 centimeter, then I multiply by 15, so it gives you 15 right here. So that's why I will get 15, second 30, and you're asking about 0.5. Just multiply. Yeah. So what you do, you just measure with a ruler the distance in centimeters, and then you just multiply it by the scale. So in this case, 1 centimeter is equal to 15 meters. So that's how you do it. If you have a different scale, then you just multiply not by 15, but you multiply by that scale that you are given in your map. So this is how it's done. Maybe this one, it was the distance was when I measured distance was 0.5. Yeah, that's how you get 0.5. So you actually measure it with ruler from this point to this point is 0.5, and I multiply by the scale 15 is going to give you 7.5. So here is going to be 7.5. And the elevation is taken from the borehole log, so it's not assumed, but okay. Okay, so what is important is if you draw it the way it's presented here, so there are different ways to draw a cross-section. If you read my book, it will be just straight line. If you find somewhere else, you will see that they have this like bars, and then they have a different color. That's okay. Either way is fine. If you use the color, what you need to do is you need to explain what this color means, and that's why you need legend. So if you just like show different colors without legend, nobody will understand what it is. So that will be a mistake. So if you use this style with the colors, then make sure that you explain what it is. If you use some kind of symbols, for example, S here or here M, you also need to explain what it means. So S, I don't know if you want to say sand or Steve, whatever it means, just please explain it in the cross-section. If you don't explain it in cross-section, it will be counted as a mistake, because whatever you show on the cross-section needs to be easy to understand for anybody. But if you put symbols and nobody knows the meaning of the symbols, then in this case, well, it's not easy to understand. So whatever you put on cross-section, don't put too much, but if there is some important information, you can put it on cross-section, or just draw it the way that I showed before, just a straight line, and just show the boundaries between each geological unit. Okay, so this will be a nice example, something that I would like you to do. Again, another way, you just do it with simple lines like the way that is shown in my book. So just line like this. But then like you need to write what it is, if it's sand or clay. If you write sand, then you don't really need any legend because it's already explained. So you don't use any symbols on the cross section. So you don't really need to explain it if you write sand. If you just put S, in this case, you will need legend and explain what S means. If you use color, just explain what it means. Okay, we have a few minutes and I'll just go through common mistakes and then we'll finish. So common mistakes made by students from my experience, common mistake, they use some symbols or colors and they don't provide legend. So that will be a mistake. They don't also provide scale, distance scale or elevation scale. They don't, that's a mistake. Also provide units. So usually I assume everything is going to be in meters, but you will need to write that. You write distance, meters, elevation, meters. The ends of borehole are connected. Okay, so I'll show you a few examples. So go back. What you can do, and sometimes what students do, they would just assume that these layers boundaries of the same layer of, let's say, what it is, clay, right? So they can try to connect it. You don't have to do that. That's okay if you don't do that. But when we actually design things, we just also need to know what is in between, right? Not only in borehole 1 and borehole 2, because it's just one point along like 100 meters. So we also need to know what is in between. So most likely, either we will have more boreholes to clarify what is in between, or we do some other test. But what we can also do, we just make assumptions that if we have about 5 meters of clay here and then another clay, maybe 7. So this is just one layer, one long layer that goes along the slope. So you can do such assumption, and at some point we'll have to do that, especially when we design structures. But when you present it in your first project, you don't really have to do that. You can just show boreholes. But if you do that, make sure that you connect the boundaries of each layer with a dotted line. So it's dashed line. It's not straight line like this. So in this case, what it means is that you make assumption that if we drill a borehole here, most likely we're going to find the boundary of between sand and clay somewhere at this depth. It's just assumption. Maybe it's wrong. Maybe the boundary goes like this. We don't know. We don't know without, because we just need more information. So, but we just make this assumption. That's why we use this dotted line. So that means the assumption. If you draw this line, that's your assumption, then it's definitely there. This one, it says, well, maybe it's there, maybe not there. That's what I'm saying. But what is what is the common mistake is that even with if you draw this dotted line at the end of borehole, that will be a mistake. This means that you assume that this is the end of the sand, this point, but it's not correct. This is just the end of the borehole. If we drill borehole deeper, maybe the boundary is going to be here. So in this case, the low boundary of sand will be at this level, not here. Many students don't understand that, or maybe they just don't care. They just connect the end of borehole and say this is the end of this sand layer, but it is not. We don't know. Maybe it is, but maybe not. We don't have enough information to make the statement. What we just know for sure, this is the end of the borehole log. Okay, so this is just very common mistakes. Units missing, scale missing, legend is also missing, end of borehole logs. How can we find out how far it goes rather than just assuming? We cannot really find out unless we drill borehole deeper. We can do more tests. We can do another test. We can do a geophysics, for example, something, or we can do an SPT test. But then again, we will just need to drill a borehole and deeper. So that's why it's always better to just go with assumptions that with very like clear 100% statements. Yeah, this is there. Because what if it's not there, and then you're going to be in trouble. And if you present it as your report in the industry, and then they just design based on your findings, and then what if that's not the end of the sand, and then you're going to be in trouble and probably will go to jail. So make sure that you won't go to jail. So just always be careful with all the like natural data that you analyze. Make sure that it makes sense and don't make overstatements. Just state what is like what you know. Do you have any more questions? Because it's already 11 and we're gonna finish this tutorial. I hope it was useful so you know better how to analyze data from SPT tests. And I hope you have better understanding or some understanding how to draw cross-section. So this is like a process that you will start drawing it, and then if there is some mistakes, you just correct it. I would recommend just use pencil and eraser when you draw a cross section. Don't draw it with a pen. Okay, is this what? No, your quiz on Friday will be based on the laboratory that we're gonna do tomorrow. For some of you, Thursday, Friday. That will be based on those laboratory tests that you were supposed to do face to face, but unfortunately you cannot do face to face. And the questions from the tube. I don't think there will be any questions from the tube. So the questions that we cover right now is more will be in your project, or it will be in one of those bigger quizzes that is worth 10%. Yeah, so whatever we do in the laboratory, that quiz will be about that. I don't think there's anything else. Yeah, look, with site test, site penetrometer, vein sheet, dynamic on penetrometer. Yeah, so this quiz is for those who will do online laboratory this week. If you did your laboratory last week, you don't have to do that. You just very lucky, I guess. But sorry, we cannot do it face to face because of lockdown. We would like to do all labs face to face, and even this tutorial, I would like to do it also face to face. It's just not possible. But hopefully, I don't know what is going to be with lockdown. Maybe by week 4 it will be better. Okay, guys, thanks for joining the session. Multiple labs if we miss something. Yeah, there is 3 different laboratories that is going to be, well, basically exactly the same. I mean, depends on your questions, but the content will be the same. So if you don't do one tomorrow from 12 to 2, you can attend one on Thursday from 9 to 11 or Friday from 9 to 11. So yeah, but this is only because it's online. You can swap this your laboratory, but hopefully when we go back to face, then you just attend your laboratory, the one that you have. Yeah, we have a lecture this afternoon. I forgot. I have actually another lecture from 12, different subject. I need to get ready for that one too.